This video goes with the assignment Encore 3-1, and I'm going to do some examples of some of the equations on this page. So I went ahead and pasted problems 1 and 3, and also problems 5 and 15. I'm sorry, 5 and 7. But I've transferred these over to a single page. So I'll do one at a time because I just don't have enough room right here that they provide me on the handout. So students, you might think about doing this on notebook paper. So we're going to start with problem number 1. And when I look at this, I have 3x plus 4 plus 2x plus 5 equals 34. And the first thing I'm going to do is I'm going to try to combine like terms. So if I put the 3x and the 2x together, they're like terms. So 3x and 2x becomes 5x. I think when I look at some other terms up there, I have some constants, some numbers. The positive 4 and the positive 5 go together. I'm going to put those together to simplify, and that would be a positive 9. All of this equals 34. Once I combine the like terms, this should be a pretty simple problem. Some students are doing this. They're putting a dotted line down the equal sign just to separate the two halves of the equation. Remember, I'm looking for the variable. I find the variable x. I want to get that all by itself. So the x happens to be on the left side of the line or the left side of the equation. So when I isolate the x, that means I need to get rid of the coefficient 5 and the positive 9. Let's save the coefficient for last. So what's the opposite of a positive 9? Negative 9. We must do that on both sides of the equation. Here's my sum line. 5x and nothing is 5x. Remember, positive 9, negative 9 go away. And what does this equal? Well, 34 positives. Take away 9 negatives. That leaves me a total of 25 positives. My last step is just to do the opposite of multiplying by 5. So 5x means multiply by 5. We'll go do the opposite, divide by 5. Do that on both sides of the equation. 5 over 5 is 1. 25 divided by 5 is 5. So x equals 5. Okay, the next problem, that was pretty simple. Students should be able to handle that. But now we have some fractions, and that's what we're really talking about here. So I'm trying to combine like terms, and when I look at these two things right here, I'm thinking one's a fraction, one's a whole number. And if I want to try to combine just the numbers, I got a positive 6 and a positive 1/2, and I really don't want mixed numbers if I can get away with it. So let's just change everything to a fraction. So I'm going to leave this at 1/2 x. When I put my two numbers together, well, let's just talk about the x's. So I have a negative 2x. If I would like to keep that as a fraction but still equal to negative 2, I'm going to make that a negative 4 over 2x. That means the same thing as a negative 2x. Okay? In fact, I think I'll change that to a negative 4 over 2x. I'm going to put the minus sign right here. So negative 4 over 2x. And when I look at my two numbers, I have a positive 6 and a positive 1/2. Let's keep this positive 1/2. It's already a fraction. Well, let's change this positive 6 so it has a denominator of 2. So I'm going to make a positive 12 over 2. That means the same thing as a positive 6. Now I've changed everything to fractions, and all of this equals 7/2. And now let's see if we can just go ahead and do what we've been doing before. Let's combine our like terms. If I put these two together, and I'm sitting there thinking, well, I'm going to keep the denominator 2. So when I put these together, I have a 2 for a denominator, but a positive 1 and a negative 4 put together is a negative 3. So negative 3 halves x. Okay, let's see if we can go ahead and put the numbers together. I'm just going to go ahead and put these two together right here. I'm going to keep the denominator 2. They're both positive, so positive, and of course I have 2 for a denominator. And 12 and 1 put together is 13. And all of this equals 7/2. And I'm going to go ahead and just do the same thing I've been doing before. Draw my line down here. I want to try to isolate the variable. Well, the variable in this case is x. So I want to get x all by itself. And when I look at this, I'm thinking, okay, well, let's save the coefficient of x for last. That would be the fraction negative 3/2. Let's do this first. Let's do a negative 13 over 2. And let's do a negative 13 over 2. And let's just see what we get. So I'm going to do my sum line. Of course, these cancel out. We wanted those to go away. So I have my negative 3/2 x. And what is this going to equal? Well, when I put 7 positives and 13 negatives together, that gives me a negative 6 over 2. And now, how do we get x all by itself? Well, there's a rule in mathematics that says that if we multiply by the reciprocal, If I multiply by a negative 2 over 3, anytime you multiply a fraction by its reciprocal, it becomes 1. I got to multiply this side by a negative 2 over 3. And let's just see what we get. These should cancel right here. Let's see, 2 goes into 2 once, 2 goes into 2 once, 3 goes into 3 once, 3 goes into 3 once. A negative times a negative becomes a positive, so there's my positive 1x. Let's just do some multiplication over here. Let's see, negative times negative is going to be a positive. I really don't need that equal sign here. Let's just see if we can just bring it down. Let's see, 2 goes into 2 once, 2 goes into 2 once, 3 goes into 3 once, 3 goes into 6 2 times. And so when I multiply the top, I have a positive 2 times a positive 1 over 1. So x equals 2. Let's see, I've got a couple more real quick ones. These shouldn't take long for us to do. Let's see, on this one right here, the students know how to use the distributive property. They're going to multiply 2 times x, go back and multiply 2 times a positive 1. So here we have 2 times x is 2x. 2 times a positive 1 is a positive 2, plus 4. All of this equals 12. Let's see if we can simplify the left-hand side. I can put these two together. So now I have 2x plus 6 equals 12. Remember, we want to isolate the variable. I want to get x all by itself. I think I'm going to get rid of this first. Minus 6 minus 6. Remember, these go away. That's what we wanted. So now I have 2x equals 12 positives, 6 negatives is 6 positives. Divide by 2, divide by 2. I think x is going to be a positive 3. Students should not have trouble with that equation. And the last one I want to do is this one right here. And this is pretty simple too. Our distributive property will take place kind of in the middle of the equation. We're going to multiply that negative 3 through the parentheses. So I have 15, but a negative 3 times x is a negative 3x. By negative 3 times a negative 1 is a positive 3. All of this equals 12. I'm going to put my two numbers together. So now I have 18 minus 3x equals 12. And once again, I want to isolate the variable x. So minus 18, we'll get rid of this. Remember, we always save the coefficient for last. These go away, positive 18, negative 18, so I have a negative 3x equals 12 positives, 18 negatives. Put that together, I get a negative 6. My last step, divide by negative 3, divide by negative 3. What does x equal? X equals a positive 2. Hopefully this will help you with some of the equations on that ENCORE 3-1.